So, my name is Trey, and I use Python to teach, actually. I help people improve their Python skills, use Python more effectively. So, as Sam mentioned, I run a Python skill building service. It's called Python Morsels. I send out one Python exercise every week there. If you think that logo is adorable, I have lots of stickers, and I would love to give you stickers. Find me afterward. The other thing that I do is I do Python training for teams through my company, Truthful Technology. I would love to talk to you about how I can help you and your coworkers learn Python more effectively and use Python more effectively as a team if you're interested in that. So that's me. We're going to talk about classes. I am really tempted when I talk about everything in this talk here to use the phrase Pythonic classes. That word Pythonic, though, it's a little bit controversial, and I'd say it's a little bit overused as well. We use that as kind of a hammer to talk about everything in the Python world. So instead, I'd like to say we're talking about friendly classes. Friendly classes are classes that are friendly for other people to use. It's friendly to make a friendly class. It's easy to make one, and it is easy to use these. So the things that friendly classes have in them are a nice string representation. They can also be compared to each other, at least in ways that make sense. And whenever possible, whenever it makes sense, they support operator overloading to allow themselves to be addable, hashable, iterable, those types of things. I want to talk about two examples here, and then we're going to discuss some different ways that we can make classes of these varieties. So the first example is a month class. It's kind of a silly, kind of a contrived class. What we want to make with this class is something we want with pretty much every class. We want to be able to construct this class and pass some things to it. What we need for this is a dunder init, an initializer method, which you've probably all seen before if you've made a class in Python. We want a helpful string representation. So this string representation here, in order to get that, we want a dunder repr method. A dunder, by the way, I've been saying dunder a couple times here. Dunder stands for double underscore, as I'm using it here. So double underscore init, double underscore. These are essentially special methods that act as a contract between us and the Python interpreter. We're saying we want you to hook into our class to do some special things and these dunder methods are used for those. So this is pretty common here, to see a dunder init and a dunder repr. If we wanted our class to be able to be comparable to other classes, we would need to support equality from that, and we want to support inequality. To get those, we have to do something else. We have to make a dunder eq method. You used to have to make dunder ini as well. In Python 3, you get that for free. We might want to go further than this, though. We might not want to just say, can we ask one object, is it equal to another? But can we ask an object, how does it compare to another in some other way? We want to make these orderable as well, or sortable, if you'd like to think of it that way. For that, we need less than. The less than operator requires dunder lt. Greater than requires dunder gt. Less than or equal to is dunder le, and greater than or equal to is dunder ge. We've just ballooned our class here. It is much larger than it was before. So after this, our class is going to look pretty big. It's got a lot of code in it. You might notice with this code, there's a lot of duplication here. Most of these methods are actually almost exactly the same method. Namely, all of those comparison dunder methods are nearly identical. The only thing that's different about them really is the operator that we use for each of them. So there is fortunately a helper function in the standard library to make this a little bit shorter, to make making a class of this variety a little bit easier. It's called functools. It's called total ordering. It lives in functools, though. Functools is a module that lives in the standard library. Total ordering is a class decorator. We can use this to decorate our class, and by implementing just two of these methods, dunder eq and dunder lt in this case here, we get for free all of the other methods. It kind of extrapolates how those should work. This is still boilerplate code, though. All of the code in this class is code that doesn't really need to exist. So we will take a look at a better way to make this class later, towards the end of this talk, actually. First, I want to talk about one more example that we're going to focus on primarily. We're going to talk about making a point. So this is a class that represents a three-dimensional point, x, y, and z coordinates. Same as before, we want our class to be able to accept arguments, so we need initializer. We want a nice string representation. And we want our point objects to be comparable to each other using equality and inequality. What if we also want our class to be unpackable, meaning we can use it with multiple assignment? So this is a little bit odd. We're saying x comma y comma z equals p. We'd expect that to work and give us those coordinates there. For this, we need to add a dunder iter method to get iterability. So this might be a little bit counterintuitive. Iterability doesn't seem like it's related to multiple assignment, but it is. That's how Python implements this by default under the hood. So iterability is the thing we would need to implement for multiple assignment. If we wanted to go even further and maybe make this class something that it's frozen, it's set in stone after we've made it, we would want to make this immutable. So an immutable class is one that you can't change after you've created it. So what that means is if we tried to say p.x equals 4, we get an error. To do this, we need to do something a little bit weirder than making a dunder iter method. We need a dunder set attr, which is kind of advanced. I'm not going to talk about how to do that. You can look that up on your own if you want it, but that's one way we could make an immutable class in Python. If our class is immutable, after immutability, there's another logical thing we might want. We could say, well, our class is immutable. We want to use it in sets, or we want to use it as keys in a dictionary. For this, we don't get this for free. We should get it for free, but we don't get it for free. Python doesn't know how to give it to us. We need to tell it with an under hash method. So we need our class to be hashable. So again, we've written a lot of boilerplate code here. What this code ends up looking like if we actually write an implementation for each of these methods is this. This is one possible implementation, at least. So this class isn't actually that long. I'm not sure how many lines of code this is, but each method is pretty short. Some of this might be a little new to you. For example, in dunder iter, there's a yield. If you haven't seen that before, you can Google generators and iterators and how to make them on your own. But in general, this is pretty much all boilerplate code, which means this is copy-paste code time. We should go to Google, look up how to make a class like this, copy-paste it, and change it for our own use. So we shouldn't have to write this code if we could just copy-paste it from somewhere. Python should be able to make this code for us. Fortunately, there is a tool in the standard library for writing code that is similar to this. It's called NamedTuple. So NamedTuple is built into Python 3. It lives in the typing module. To create a NamedTuple class, you can inherit from NamedTuple and use type hints to define the attributes that are on your class, so X, Y, and Z there. The class that we get from this has a friendly string representation, and it has nice default comparisons, meaning equality and inequality. And these classes, just as we want them to be, at least for this point here, they're immutable, just like tuples are. By the way, if you've seen NamedTuple before, but you were in Python 2 land, or maybe you're using code that was worked before Python 3.5 or so, which is when they added NamedTuple, there was another NamedTuple that lived in the collections module. This one's a little bit different in syntax. You can look up the differences between those later. So I don't actually want you to do this. I don't want you to use NamedTuple to make a point. The reason for that is NamedTuples have some downsides. NamedTuples inherit from tuples, which means they inherit all of the features that tuples have. So they can be ordered, which could be nice. For a point, it's a little bit weird to order points based on their x, then y, and then z coordinates, which means we don't really want this. We would want to disable this behavior somehow. They can also be added to each other, which actually seems nifty. It seems like it would be nice to be able to take 2 points and add them to each other. But the thing you get back probably isn't what you were expecting. We don't get 1, 2, and 3 added to 4, 5, and 6. We get 1, 2, 3 added to 4, 5, and 6. We get a tuple back of 6 elements. So the same is true for multiplication. We can take 1, 2, and 3, multiply this point by 2. We don't get 2, 4, and 6. We get 1, 2, 3, 1, 2, 3. So NamedTuples are lovely, but they're tuples. They have a length. They have other features that are tuple specific. These are tuple-y features. They're trying to act like tuples. NamedTuples are useful, but you have to be careful while using them. So you could try to overload or override all of these methods here to fix this issue. This is really awkward. In fact, this code is buggy. I don't actually even think it works the way you might expect in some cases. Finding and removing features from NamedTuples is more of a pain than just adding the features that you want in your class, usually. So don't go about trying to use NamedTuple and find and remove features that you don't want. Instead, add features that you do want. Make your class support exactly what you want. Don't go about removing functionality that you don't want from some other class. So don't use NamedTuple unless you are trying to make a class that acts like a tuple. One alternative to NamedTuples is attrs. Attrs is a third-party library, and it makes creating classes with a lot of common features really easy. So you can get attrs by pip installing it, and after that you can use it by importing attr without the s, which is a little bit odd, and then decorating your class with the attr.s decorator. That auto attribs equals true thing, that allows us to use type hints, just like we used with NamedTuple a moment ago. So by default, attrs classes get a nice string representation, just like our NamedTuple had and just like we're expecting, and they can be logically compared to one another using equality and inequality. But they can also be ordered the same way that NamedTuples can, which is a little bit odd in this case. We don't want this to work with our point objects, at least. And they aren't iterable, and they're not immutable, meaning we can't use them with multiple assignment, and we're not going to get an error if we try to assign to attributes. So our point class doesn't quite work out of the box with attrs yet, at least. If we want our point class, if we want to make our point class using attrs, we can set frozen equal to true as we decorate our class here with attr.s. This makes our class immutable, meaning we can't modify those attributes after we've made them. What we've also done here is we've defined a dunder-iter method, the same way we did manually before. This is making our class work with multiple assignment. It's making our class iterable. We've also disabled comparison operators. Unfortunately, disabling comparison operators means we have to manually implement a dundereq method if we want our class to use equality, and we have to manually make a dunder hash if we want our class to be able to be used in keys and dictionaries or in sets. That's just kind of the way that attrs works there with comparisons. So attrs is a lot more powerful than NamedTuples, but it can take a little bit of playing with to get it to do exactly what you want for certain use cases. And it is a third-party library, which means you will need to pip install it in order to use it, unlike NamedTuple. There is an attrs-like library that's actually bundled with Python, though. It's called dataclasses. So dataclasses are essentially, it's a simplified version of the attrs library that doesn't support nearly as many features, but it is built right into Python. To use dataclasses, you will import dataclass from the dataclasses library, and you'll decorate your class the same way you would with attrs. The syntax, again, relies on type hinting, so we're using type hinting all the way here. Just like with NamedTuple, this is just like with attrs, and maybe just like with other libraries if you're already using these. The point class that we get back has a nice string representation, and it supports comparisons, just like what we're looking for. It doesn't, though, support ordering, at least not by default. So in our particular case here, this is good. For our point, we don't want it to be orderable. This doesn't quite work the way we want it to yet. Our point isn't yet immutable, and it's not iterable. So if we try to use this point with multiple assignment, we'll get an error, because our point class is not iterable, so we can't unpack it into 3 variables. If we try to assign p.x equals to 4, this works, which isn't what we're looking for. We want this to give us an error, because this should be an immutable object, meaning we shouldn't actually be able to change it after we've constructed one of these, after we've created a point. So to make our point class iterable, to make it immutable, we can do this. To make it iterable in particular, we can add a dunderIter method, just like we've been doing this whole time. This is no different from attrs, no different from making this manually. What we could do instead, though, is instead of yielding from self.x, self.y, self.z, we can actually use a helper that's built into the dataclasses library. It's called asTuple. So as tuple converts our data class to a tuple, it gets those three attributes from it. This allows us to more easily specify things like dunder iter. So kind of nifty. Doesn't save us too much code there, but it does allow us to be a little bit more generic with our code. So the point object that we get back is now iterable, meaning that we can use it with multiple assignment, which is great. It's not yet immutable. To make our point object immutable, we can use frozen. Setting frozen to true in our data class decorator makes our point immutable. Once we've frozen it here, if we try to assign p.x equal to 4, we'll get an error, as we're expecting. So the class that we ended up with here, it's iterable, it's immutable, it's comparable, and it has a nice string representation. It's not orderable. It doesn't have a length, and it doesn't have all those other weird things that we got with NamedTuples. It does exactly the thing that we're looking for and no more. So using data classes, we've made a friendly class, which has exactly the features that we want, and this is all in less than 10 lines of code. I think this is pretty cool. When I told you before that data classes are included in the Python standard library, what I meant was that they're included in the Python 3.7 standard library. Who is using in production as your main Python version, Python 3.7? OK, yeah, that is very few people in the room. I am not raising my hand. Python 3.7, it was only released back in June or so. Normally, it's a good practice to not use a new version of a library until it's got, at least a sub-minor version there that's been bumped or something of the sort, unless you're kind of bleeding edge. So for those of you who aren't yet on 3.7, which is most of you, you can get data classes by pip installing it. It's actually also available as a third-party library. Who is using Python 2 primarily in production? You can raise your hands. We're all friends here. We're not going to judge you. OK, so that's quite a few people in the room. You're all waiting, I assume, until the last minute, December 31st, 2019, until you upgrade to Python 3. That's perfectly fine. That's your call. You can't use data classes, unfortunately. If you're looking to use a helper in order to make friendly classes, you could use attrs. Attrs supports Python 2, and it supports Python 3. Regardless of whether you're in Python 2 or Python 3, if you're looking for more features than data classes provides, I would also look at attrs. Attrs is a little bit more feature-rich than data classes are, and it actually predated data classes. In fact, the inspiration for data classes was attrs, this third-party library. So check it out if you haven't yet. Not quite the last thing I'd like to talk about, but one of the things I'd like to talk about here is some common use cases for data classes. So I intend this section to be kind of a recipe book. I don't mean it to be an infomercial for data classes, but I think it's kind of an infomercial for data classes. So without any other customization, data classes give you a good string representation. They allow you to compare different data classes to each other using equality and inequality. And that's pretty much it. They don't really do too much for you out of the box. These things are nice, but it's not groundbreaking here. This might be all you need. If it's not, though, they do provide a couple other things. So as we've already seen, you can make a data class immutable by setting frozen equal to true. This is a really big feature, because this is a pain to do yourself in your own classes. This also, by the way, makes our classes hashable by default. If that's a thing that you're into, if that's what you're looking for, you get that by default, which is nice. You can also make data classes iterable. Now, this is actually unrelated to data classes. For any class in Python, you can make a dunder iter method and make your class iterable. The thing that's data class specific is that asTuple function there. That is a helper function that makes it so we can tell the data class, I don't care what my attributes are, just give them all back to me when I iterate over it. Something I haven't shown you yet that data classes are good for, we're going to jump back to our month example that we talked about at the very beginning. We talked about making our class, our month class, orderable, meaning we could use less than, greater than, all the various comparison operators. So to do this with data classes, we can set order to true when we're decorating our data class with that data class decorator. This makes our classes orderable lexicographically, which is a word that I never hear people say, and a word you probably never will say. You don't need to know it. It basically just means the way tuples, lists, strings, everything in Python is typically ordered. It's lexicographically. So that's what you get if you set order to true. One more thing I'd like to discuss that's not at all data class specific is dunder methods. So one of the secrets to making a friendly class, not the only secret, but one of them, is embracing dunder methods. So this class here implements dunder iter, dunder add, and dunder sub. Dunder add and dunder sub make this class support addition and subtraction, the way we would expect them to support addition and subtraction. That dunder iter there, it's essentially just making our dunder add and dunder sub a little bit simpler in implementation, and it's making our class iterable as well. Sometimes people call these things, these dunder methods, magic methods. I don't want you to call them magic methods, or at least if you call them magic methods, I don't want you to think they're magical. They aren't magical, they're not scary. These are methods you can make yourself, and you should if you want to make a friendly class. Dunder methods make friendly classes. So before we wrap up here, the last thing I'd like you to consider seems kind of maybe like an off-topic issue, but I think it's actually very on topic, whether you even need a class. So this is a class that represents a matrix. This class accepts a string that represents this matrix. There's spaces and new line characters, kind of noting how this matrix looks. The rows attribute on this matrix object will give us back a list of lists representing all the numbers in this matrix. The columns attribute gives us back the transpose of those rows. This class here does not need to exist. I say that because we could replace this class with two functions, matrix from string and transpose. We can call the matrix from string function the same way we called our matrix class before, the same way we constructed our matrix class. Instead of giving us a matrix back, though, it gives us back a list of lists. This is the same as the rows attribute that we got before. If we pass this list of lists here, these numbers, to the transpose function, we'll get back the transpose of our matrix, which is the same thing our columns attribute gave us before. You do not always need classes. Friendly classes are great, but the friendliest Python code sometimes doesn't have very many classes at all. So when making classes, I'd like you to consider whether you even need a class, because you often don't. It's the first thing I want you to consider. There's a talk on this subject I'd recommend watching. It's kind of an old talk, but it is very much still relevant today. It's called Stop Writing Classes. It's by Jack Diedrich. If you do decide, after watching this, by the way, the link to that talk and some of the resources will be in my last slide here, so you don't have to go Googling it. If you do decide that you do in fact need a class, you should make your class a friendly one. Meaning using your class should feel almost as natural as using one of the built-in Python classes, one of the built-in Python objects. Creating a friendly class can involve a lot of boilerplate code. It's hard for you to make the life of the person using your class a little bit easier. But the data classes library can help you with this. It comes bundled with Python 3.7, and on any version of Python 3, you can pip install it. If you're on an earlier version than Python 3, if you're on Python 2, or if you need more functionality than data classes provides, there's always the attrs library, which is a third-party library that is lovely and data classes is inspired by. So if you'd like to dive a little bit deeper into the things that I just talked about here, if you want some related links, you can go to that URL there. That's trey.io/nbpy2018. That is all I've got for you. Thank you.
Thank you, Trey. Thank you. I guess you'll be hanging around in the park after this talk or something like that?
Yes. Yeah, I'll be in the park after.
Trey's going to be in the micro park track after his talk if you want to ask him some questions. So you're a speaker last year, and so you got one of the first edition lovely North Bay Python water bottles. So this is a second edition. It is, in fact, a new model of Camelback bottle, so it will be different. It's also a lovely different color. It's fetching Andrew Godwin Sapphire.
Ooh.
So yeah, thank you again. Hopefully we'll see you next year.
Yes, thank you, Chris.